Today in episode 13 of the CySec 101 training series, we are going to go through Linux shells, and this is a part of the Cybersecurity 101 pathway of TryHackMe, and in this particular module that we're on, we're going to be talking about all the command lines. So this is actually the third video in the command lines module. In the last two videos, we talked about the Windows command line and Windows PowerShell and so on and so forth. And today we're going to be talking about my favorite shell, which is the Linux shell. And this is where I have most comfort in. And I mean, I've done multiple videos on Linux, as well as the Linux Plus training series, which was recently dropped. And we did 3 videos just on the Linux command line. And the last video in that series was the Linux scripting, shell scripting, and that's all inside of the Linux Plus playlist. So this is one of those topics that I'm actually very comfortable with, and I can share a lot of content with you on this topic. But because we are still in the CySec 101 series, I'm not going to go too crazy with sharing like all the extra information. I'm going to stay with the path. So with what we're getting inside of the actual training series from TryHackMe, I'm going to stay here and I'm going to talk about the topics that we talk about. And it's actually nice because they do cover some good basics, but then we actually do also go into some basic scripting fundamentals as well. So by the end of this video, you'll get a chance to learn all of the basics. You'll get a chance to get system information, run basic command lines for file navigation, so on and so forth. But then what we're also going to do is create a couple of shell scripts as well, so you get a good grasp of what it is that we're doing in this particular video. So really excited about this one. Let's get into it. This video is sponsored by the Hackaholics Anonymous membership community, and as a part of that membership community, you will get access to a bunch of perks. For example, the Discord servers that are available for every single level that we have in that membership. There are Python automations that are available. There are exclusive content, exclusive downloads, early access to the content, live streams, and a variety of other things that are exclusive to the Hackaholics Anonymous community. And I highly recommend, if you haven't checked it out, to actually check it out. If you want, you can go to the link in the description below, or you can go to the homepage of this channel, click on the join button, and it'll show you all the different tiers and the perks. Or you can just go to youtube.com/@hankhackshackers/join, and you'll be able to take a look at all of the perks and everything that we have in Hackaholics Anonymous. So if you haven't checked that out already, I would highly recommend that you check out the Hackaholics Anonymous membership community. That being said, let's actually jump into the intro for the Linux shells video. Okay, so if you've ever used any kind of a computer, you are most likely very familiar with the graphical user interface, which is basically you see the icons on the desktop, you get to click around, you get to open up a file browser, so on and so forth. And that's what most people are used to. And in a lot of cases, you can basically just click around until you find what you're looking for and browse, right? That's one of the big things about a graphical user interface, is that you get to browse and you get to click around until you find the thing that you're looking for. If we were to compare that to the command line, the command line really requires that you know what you're looking for, and you essentially just search for it, or you type the script or whatever it is, and you get what you want, right? So it's the opposite of browsing. The command line typically just requires that you actually know exactly what you're doing. But what happens is that instead of having to click around and take your time and all that, you get your result very quickly. And the command line is not as resource intensive. It doesn't take a lot of CPU usage. A lot of times you can run the command line of Linux inside of a Raspberry Pi, which is like this really small computer that's probably the size of your phone. And it's just very resource, what can I say? It's not intensive with the resource. I'm trying to find the opposite of the antonym or of intensive, but it's easy on resources, right? It doesn't take too much resources. Another good example is that if you go to a restaurant and you have 2 options to get your food, one of them would be to just order the food from the menu, which means that essentially you just have this set series of options that you can choose from, and then you tell the waiter what it is that you want, and the waiter will deliver whatever you chose from the menu. The other option is you know exactly what you want to cook, you know what ingredients you want to use, and you go to the kitchen yourself, and then you prepare the food exactly how you want it, instead of choosing from a pre-selected, predetermined list of options. And that's the difference between the GUI or the GUI and the command line. So if you're using the GUI or the GUI, you get to choose from the pre-selected applications and options and the things that are available for you. If you use the command line, you get to do exactly what you want. And that's kind of the big key difference, or the analogy that has been presented to us in this particular exercise. Now, you have most likely seen a command line. So if you've seen any of our other videos on PowerShell or the Windows command line or Linux or anything like that, you probably know what a command line looks like. If you've never seen any of the other videos that I've done, you've probably seen it inside some kind of a hacking movie, right? Or a hacking scene inside of a spy movie or something like that, where it's basically this black screen, and on the black screen, you get to see the white text, and the guy is just typing away, and then all of a sudden at the end of it, he has hacked into the system, quote unquote, right? And that's basically what the command line is. So you, at the very least, you've seen it somewhere. If you haven't seen any of the videos on this channel, you've probably seen the command line somewhere. And so as soon as I load the shell that we have over here, you'll be like, oh, I do recognize this. And then it's just about, okay, let's go through it and learn how to use it. So the objectives that we have for this video is to how to interact with the Linux shell using some of the basic shell commands, exploring the types of shells that are available, because there are actually a variety of shells that are available, and then just writing some shell scripts so that you can kind of get your feet wet, so to speak, dip your toe in the water, so to speak. And that's basically it. We did the Linux fundamentals module, which was at the very intro of this specific training series in CySec 101. It was episodes 4, 5, and 6, I believe, are the actual Linux fundamentals module. And so, you know, part 1, part 2, and part 3 is what's available for the Linux fundamentals module. And so if you haven't seen that, that is the absolute beginner series of videos for Linux. And then I've done several other videos as well, like the Linux Plus series that's available as a playlist that you can access. So this is a continuation of the Linux fundamentals in the CySec 101 training series. So that's kind of where we're at in our order of content, so to speak. So the very first question is, who's the facilitator between the user and the OS? And that's actually the shell. The shell is where the user inputs all of their commands and their requests that they want to make from the OS, and then the OS responds with whatever that you want it to do for you. And it'll either give you a correct response where it gives you the result that you want, or it'll give you some kind of an error message saying that I can't process that request because of XYZ reason. So the facilitator between the the facilitator between the user and the operating system is the shell, right? That's the bridge that connects those two entities. So that is what we got for our introduction. So now we're gonna start up our shell and then learn how to interact with the shell. All right, so if you are logged into TryHackMe as a paid user, well, you actually need a paid membership to be able to access the virtual machine that we have here. So you can either use the virtual machine directly inside of the browser, which is what I'm going to do, or you can connect to the VPN of TryHackMe by using OpenVPN. That's the main VPN software that they use for their VPN configurations. So you can either use your own computer and connect to the virtual machine via OpenVPN, or you can just log in and start the machine as so. And then basically, we'll run all the commands inside of the shell because we're not going to get a graphical interface. We're literally just going to get a shell. So it'll be very, very straightforward to interact with this thing. This username and password we're going to need later on in this room. So if you are going to connect to it via OpenVPN, you would actually need to use this. The IP address is going to be different for you than it is for me. So if you try to connect to this, you're not going to succeed because this is only available for the next hour for me inside of this video. So that's the piece right there. And then the rest of this is going to essentially be the commands that we're going to end up running and the questions that we're going to answer. So instead of reading all of these commands and then demonstrating the commands, what I'm going to do is I'm just going to open up the shell, and then we're just going to start typing away, and we're going to start interacting with the Linux shell that we have available. So it'll be, I would say it'll be a little bit more friendly for you as a student to see the demonstrations of these things instead of me doing a lecture and then trying to explain it later. So there is going to be a couple of sections inside of this video where I will have to explain because we don't have internet access from the computer that we're using or from the virtual machine that we're using. We're not going to have internet access. So there are going to be a couple of sections where I do have to explain it just based on the lecture documentation that we have. But the rest of the stuff we're actually going to be able to implement and kind of run and practice these commands. So if you don't have access to this machine, if you have access to your own Kali Linux machine, that's all good. You can still run exactly the same types of commands that we're running here. And this actually even works with Mac OS as well, because Mac OS is Unix based, which is very similar syntax to Linux. So if you actually type pwd for print working directory inside of Mac OS, it'll actually give you a result. And that's very different with what happens inside of Microsoft Windows. So Mac OS shells are actually quite similar to Linux shells. And most of the commands that, or actually I think all of the commands that I'm going to run inside of this window today, if you have Mac OS, you can actually run them inside of your own terminal inside of Mac OS as well. So that having been said, all of that taken out of the way, I'm going to open up this, this window here, and then we're going to look at the full screen view of our Linux shell. So we have this thing that's going to be on the right hand side. I'm just going to open it up as full screen so that we can get access to it, and then we'll run all of our commands. So let's go. All right, so here's the shell. Basically, whenever you log into Linux, this is kind of the introductory screen that you always get. It tells you how to access documentation for your current distribution, which is me. I'm running Ubuntu, and you know, how much of the RAM as well as the CPU is being used, and just some other general information. For example, the amount of updates that can be applied, etc. So none of these is relevant to us for the scope of this particular room, but this is basically the introductory screen. Now, the very first command that you're going to learn is how to type clear and then press enter, and then it just clears the screen for you. And then this is what the command line actually looks like. So I'm going to zoom in on this a little bit so that you can actually see what's going on. And this is basically it. This is the command line. You are the user, or I am user. My host is TryHackMe. And this is usually what it looks like anytime that you're logged in to your terminal. So it could either be Mac OS that actually displays it this way. It'll actually display your username at your host name, or any remote shell that you're logged into, or basically any Linux server that you're connected to, anything of the sort. It displays the syntax for you like this. This is for bash as the shell. Once we switch to the ZSH a little bit later on in this room, we'll see that this is actually going to change, and the intro to our command line is going to be different. So that is it for the very, very basics of the introduction. So the very first command that you need to learn, if you have never interacted with Linux before, is going to be the command that I actually always run anytime that I'm connected to a remote shell, which is print working directory. So we do this in a lot of pen testing exercises as well. When you actually get a remote shell into your victim machine, you want to know where you landed when you logged in. You want to know what location inside of the file system that you're in when you logged in. So it prints your current working directory, which is, in my case, I am inside of the home. So this is actually the root. So let's talk about that. So this is the root partition, which is represented by this very first /. And then inside of the root partition, there is the home partition that houses all of the users that would be on this machine and their home directories. So I am currently inside of the user home directory, which is my current user. That's who I am. So if I type in who am I, it says you are user. So this is actually my username is user. It's kind of confusing, but whatever. So my username is user, and then I'm inside of my directory, because every user's home directory is the name of that user. Okay, so that's where I am currently located, and this is who I am. This is my actual username. Okay, so now what we need to do is we need to learn how to navigate around and go back and forth and things like that. So one of the other premium, the first commands, the primary commands that I run is ls, and ls just lists what is currently inside of that directory that you're in. So for example, in my user directory that I'm at right now, there's a shell script called flag_hunt. Now you don't see the underscore here because when you're inside of the Linux command line And this is only in this type of command line. So if you're actually inside of the not Ubuntu, excuse me, like a Kali Linux or something that had a graphical interface, if you open that terminal up, it actually shows you the underscores. But in this particular case, it doesn't show the underscore. So it's a little bit misleading. But this actually says flag underscore hunt.sh. And that's basically the only thing that's listed inside of my current directory. Now, there are other items that are actually here, but they are hidden because typically all of the system files and all of the hidden files that aren't relevant are just hidden. They're not available to you because for more often than not, you don't need them. It's not relevant, right? So for example, the bash history, which we'll talk about in a little bit, and then the cache configuration, and these things all start with a dot. So this dot is actually very important, and these are all hidden. So anything that pretty much starts with a dot is hidden, but it's still actually inside of the current directory that I'm in. And then there's these two dots that represent going up one position. So it will go from user to home. If I did cd and then I did dot dot, it would just take me from user to home. And then the current dot, the single dot, references my current location. So if I wanted to reference this thing, for example, I would have to do ./flag underscore hunt, and I'm referencing that specific shell script, okay? So that's basically how you kind of look at all of the stuff that is available inside of your directory. You type ls, it shows you all the things that are public view, I guess. And then you have ls-la that will list everything to you in this nice vertical list format. So that's what that first L does. It lists it to you vertically in this format, and it gives you the user, that's the owner, it gives you the group, and it gives you all the permissions for the file. And then A shows you everything that's also hidden. So it shows you all, right? It shows you everything that is currently inside of this particular directory. Now, if you wanted to find any extra options for any of these things, you can just pull up the manual by going man, and then you do the command that you want the manual for. So let's say man cd, and then, oh, there's actually no manual entry for cd. So let's say man ls, and it'll actually bring me the manual for the ls command with all of the options that are available. And then you can kind of scroll up and down to be able to see what is available here. And if you want to get out of the manual view, you just press Q, and then it gets you out of that. But it's going to be like at the very, very bottom of this. So instead of doing that, because I want to keep this in a good view for you, so I'm just going to type clear again so that we can bring our command line to the top here. So that's how you pull up the manual for anything. You just do man and then the name of the command, and then more often than not, it'll bring you a manual for that as well. So that is our most basic series of commands. Now, there's something else that we do need to cover, which is still in our basic series of commands, which is we have the grep command and we have the cat command. So this specific training series in this room doesn't give you all of the fundamentals first, and it kind of bounces you around a little bit. So I just want to keep that in mind. If you go through the Linux Plus training series and you watch the very first video in the lecture, it'll start explaining everything from the very, very ground up. If you watch the first video in the command line, which is technically the third video in the training series, when you watch the command line videos, we literally go from the ground up and we talk about all of the basic commands. So we're kind of going to start a little bit basic, and then we're just going to quickly go into the intermediate commands in this specific video, because that's basically the scope of the room that we're in. So the cat command stands for concatenate. And what it does is it prints the contents of any file for you onto your screen without actually having to go into the file. So we have this specific shell file, and let's say I don't want to open the actual shell file. I just want to list what's inside of it. So we'll do cat, and then we'll do flag, and then you can press tab, and it'll just fill in the rest of that name for you, and then press enter. And this is the content of the flag hunt script, right? So we'll talk about all of this when we actually go into the scripting portion, but this is a very basic script, right? So you have the directory variable, which is empty, and when we interact with the script, we're going to fill it in later on. There's the flag variable, which is also empty, that we have to fill in later on. And then there is this for loop that we have here, and inside of the for loop, there is this if statement, which is considered to be a conditional statement. And that's basically it. That's the entire script that we have here. We have a couple of variables, and we have an echo command, which basically just prints something onto the screen for you. And then this is where the bulk of the work is being done inside of this script. It's going to go and search for something for us, which is the flag. It's going to start searching for a flag. It's going to show us where it is, and we're going to have to go get the contents of it. And that's basically it. That's the script. But the idea is that when you type cat and anything following it, so it could be a text file, it could be a CSV file, it could be a shell script, as you see right here, it'll just display the contents of that file onto your screen for you. Now, the next command that we have is the grep command. And grep is actually a command that we use to search for something. So you can actually use grep to search for a specific entry inside of a file, or you can search for it or use it to search for a specific file inside of a directory, inside of a system, right? So it's basically a search mechanism. So let's say in the file that we had right now, the shell file that we had, I want to search for the word flag. And then so the first thing is you do grep, and then you give it the term that you want to search for, and then you give it the actual file that you want to hunt or search through, which would be the flag hunt. And then now we can see that, okay, so in the first comment here, it says it's going to define the directory for the search to our flag. Then second comment is defining the flag that it's going to search, and then we have the actual flag variable. And then there's also the first line in the iterative statement that is the grep for the flag variable. And then there's also checking if the file contains flag. So basically any line that includes the word flag will be printed onto the screen, and it says, yeah, inside of this specific file, there's a bunch of different flag entries, right? Or instances where the flag keyword shows up. So that's how you use grep to search for things. You can use grep to search for essentially a bunch of different things. So I could actually probably even do, I'm going to try this. Let's see if this actually works. Sometimes it doesn't work. You can do anything that has the extension of log. So if I do this asterisk right here, it stands for a wildcard character, which basically means show me anything that ends with .log, right? So it could have any beginning as long as it ends with .log. I want you to show me that, and then I want to search inside of the var log location that basically has all of the files. Okay, so I guess we can't, in this particular instance of Linux, we can't use grep to search through a directory because it's telling me that, you know, the var log is actually a directory, which means that I probably can't search for that directory automatically using grep. But what I can do is I can do ls to list the contents of the var log directory and then pipe that into the grep command, and then we can probably pull that out, right? So when you pipe something, and we'll cover this a little bit in a little bit as well, I'm just kind of getting ahead of the game here. When you pipe something, you take the output of the first command and you pipe it into this second command. So hopefully this actually works and it doesn't pull up anything for me, which is kind of weird because I know that inside of the var log directory, I have a bunch of things that actually have the extension of log. So that's kind of interesting that it doesn't work. But whatever, for whatever reason, we are not going to pursue this because I don't want to start troubleshooting and then get distracted and sidetracked with the rest of the contents of this video. So for the purposes of this video, we're just going to say that didn't work, and then we'll move on to cover the rest of the contents, because I just don't want, I usually always get sidetracked and I just go down the rabbit holes, and these videos end up being much longer than they need to be because I get obsessed and I'm like, okay, well, I want to find out why this didn't work, and da 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 da, and again I just lose my mind. So that is it for everything that we've covered inside of the commands that we should be talking about for this particular section. So the questions that we have here now is, what is the default shell in most Linux distributions? And that is bash. So if you wanted to see what the default shell was, we don't have any commands that are over here, but I think inside of the text of this specific section, it probably tells us that. But if we looked at, this is like one of the kind of the secret hints, I guess, that I'll give you here. if we go ahead and look at the flag hunt file again, at the very top, this is actually the interpreter that is going to be used so that the rest of these things are treated as actual shell commands. This is called the shebang line. And if you don't put your shebang line at the top here, the system, the operating system, isn't going to know that the rest of these things are actually supposed to be commands that you're going to run. And more importantly, if you don't say that I want you to use bash, then it won't know that this syntax belongs to bash. Because you can also create for loops and if statements using Python. So if I did bin and then Python, then what would happen is that this wouldn't make sense because this is a specific syntax for bash scripting. So I would need to adjust this whole thing to make it so that it fits the syntax for Python scripting. So this specific portion right here, this top line, the very first line, you're declaring what you want your interpreter to be so that the system knows how to interpret the rest of the contents of this script as that specific shell language or shell syntax. Okay, so that is what we got. And then this is the actual interpreters, right? So the question that we have over here is what is the default shell in most Linux distributions? And it is bash. That is the default shell. Now, which command utility is used to list down the contents of a directory? And that would be the ls command. Which command utility can help you search for anything inside of a file? And that is the grep command. So just like that, we've answered our first series of questions. So let's talk about the types of Linux shells that we have. So depending on the Linux distribution that you're using, there are different shells that come pre-installed inside of that distribution. And if you want to know what kind of shell you're actually currently using, you would just do the echo and then $ shell, so capital shell, and it will basically tell you the shell that your system is set up for. This is what we call an environment variable, and it's inside of your path document, basically where all of your environment variables are declared is inside of one configuration file. So if we wanted to just see what ours is in this particular instance, let me just make sure I get this right. Okay, very good. If we wanted to see what it was, we could just do echo $ shell and then press enter. And it also says that my shell is bin bash. So if I wanted to temporarily change it, I could reference the various shells that exist inside of my current configuration file for shells, which is inside of the not ls, excuse me, the cat etc shell file. And maybe that's not the right one, so let's see which one it was called. Oh, shells, excuse me. So it's cat etc shells is what we are trying to reference here. So let's zoom in again. So it's going to be cat etc shells, and then now we have, these are all of the shells that are available on my system. So there's the binary sh, binary bash, user binary bash, binary rbash, user binary rbash, and then so on and so forth. And then we have binary zsh, so on and so forth. So if I wanted to switch to any of these guys, I could just actually reference them by their name. So I could say zsh and then just press enter, and then it will change my current shell. There we go, we got that. So very good. Okay, cool. Press enter and we're good. And it is now changing. And now you can see that this actually changed. So previously it was what? It was, let's scroll up a little bit. It was user at TryHackMe. And that's how we know that we're inside of the bash shell. And then down here, now it's just turned into TryHackMe. So it's only referencing the host name that I'm installed in. And now we can see that we're actually technically switched into the ZSH shell. But again, a lot of the same things work. So if I typed ls, it'll actually still show me the flag hunt shell script. But previously, if you remember, when I ran ls using bash, this was actually turned into a bright neon green color. Also, print working directory works, right? All of the commands that we previously used will actually still work. And, you know, cat will actually still print the contents of the file in here for me. So these things actually are pretty universal. Like a lot of the commands that we use inside of the Linux shells are going to exactly be the same. So if I type clear and press enter, it'll clear the screen for me, even though I'm technically inside of the ZSH shell. So the shells themselves, they offer different functionalities, but for the most part, the commands that we run are essentially going to be exactly the same, and they're going to operate the same way. So it's not like one shell is going to run a command differently than another shell would. It's just some of the options that come with these various shells are going to be different. So I can just type in bash again, press enter, and now I'm switching back to my original bash command line. So the difference with these things, it just depends on I guess what level that you are as far as a user is concerned and what you want out of the shell. So the born again shell, that's what bash actually stands for, is the default shell for most distributions. This came or before this came, the SH, KSH, CSH, and they had different capabilities. Bash is kind of the enhanced replacement for those shells, and it borrows a lot of the capabilities that those things already have. It just kind of adds to it. It's widely used with scripting capabilities. It offers the tab completion. So as you saw, I just typed in the first portion of the word and then I pressed tab and it filled the rest of it for me, which is very, very useful. It'll automatically complete the command based on the possible match. It keeps a history file and logs all of your commands. So you can actually just type history to display all the previous commands. So let's go back into our shell over here and we can kind of mess around with that a little bit. So if I actually just type in history, it should show nothing because literally the only thing that I typed right now would be history. So that's the only command that I've currently run in my instance, because remember I switched to ZSH first, and then when I switched back to bash, and it started keeping the history of the commands, and the only command I typed in this point was history. So if I actually start doing some more commands, so we'll do ls, and then we'll do lsla, and then we'll do clear, and then we'll do cd ... to go up one level, and then we'll do cd user, come back into the user folder, we'll do ls one more time, and then clear one more time. And now if I do history, we can see that it has a history of all of those commands, right? The reason why this is actually useful is because sometimes users will input their usernames and passwords as they're interacting with different tools inside of the Linux shell. So for example, if you do a sudo switch user, meaning you want to switch to the root user to get all of the sudo privileges and the administrator privileges, it's going to prompt you to enter your password. And then if you do that, it's going to be stored inside of the history logs, which means that if somebody hacks into your machine, all they have to do is basically type history, and then next thing you know, they have access to your username and your password, or at the very least the password for your sudo user, which is, it's a very, very sensitive piece of information, right? So history is actually very useful when it comes down to pen testing and ethical hacking and things like that. But it's also really useful if you're trying to troubleshoot something and figure out why something crashed and what the user was doing prior to all of that. You just look at the history of their commands and it's like, well, why are you trying to do this? And so on and so forth. So it's a very, very useful utility when it comes down to trying to figure out what the heck is going on inside of a system. The friendly interactive shell is Fish. We did not have it available in our list of shells, and it's not default in most Linux distributions. It is user-friendly, so that's what the name kind of implies. And some of the user-friendliness is that the syntax is really simple, which makes it easy for beginners to use. It has auto-spell correction for the commands that you write. That's not available in Bash, which is another user-friendly thing. So if you misspell something, it'll actually have autocorrect for you. You can customize the command prompt with using themes. The syntax will actually highlight the different parts of your command based on what you're writing, so that you can actually know what the different parts of your command string are, which is again user-friendly. And it also has scripting, tab completion, and all the other stuff that Bash had. And then we have ZSH, which we kind of switched into already. It's not installed by default, but it is actually on our machine right now. It provides advanced tab completion, also provides auto spell correction, offers extensive customization, and has tab completion, command history, so on and so forth. So this is the main shells that we just kind of got a description of. And if you wanted to just look at them side by side, this is what it looks like. And I mean, that's kind of I'm not going to go through all this again because we just basically read through them. But if you want to pause this and just look at all the differences, you're more than welcome to do so. And that is that's it for all of our shells, or just the various types of shells that are available. So the questions that we got here is, which shell comes with syntax highlighting as an out-of-the-box feature? And that is Fish. It highlights the different portions of your command, of the syntax of your command. which does not have autospell correction, that would be bash, and which command history or which command displays all the previous executed commands in the session, and that is history. And that's it for all of these questions. So now we get to jump into scripting, which is kind of where the fun begins. The best way to think about a script is basically a document that holds a set of commands, and the script will, for the most part, run those commands in order from top to bottom. So let's say you have a repetitive task. So for example, renaming a series of files, or condensing or compressing, a series of folders so that you can create a bunch of archive files, or you need to run through the contents of a document to find everything that matches a certain pattern. There's a lot of tedious, repetitive tasks that system administrators have to do, and this is where scripting makes your life so much easier. It saves you a lot of time, saves you a lot of energy, saves your eyes from hurting. It's just a really, really useful tool. So it helps us with automation. That's basically the whole purpose of a script, is to automate something for you. And then what's nice about it is that not only does it save you time and energy, it also runs the same exact series of commands exactly the same way that it should every single time, meaning that it removes the human error element of it. Because if a system administrator is running a series of commands and they have to do it manually every single time, after the 10th or 15th one, after the 20th one, you kind of get a little bit tired and you start being a little bit lax, and sometimes you may misspell something and now you have to go redo that again. And the power of a script is that it'll run exactly the command as it should. So if you actually create it correctly the first time, then every single time that you run it, it's going to run exactly the way that it should, and it's going to save you, again, time, energy, headaches, so on and so forth. So this is why scripting is so powerful, and this is why we do it. Now, the extension of a script depends on what type of interpreter you're using. So for example, if we're using shell scripting, so if we're going to use bash or zsh or anything, the extension would be .sh. If you're going to use Python scripting, the extension would be .py. If you're going to use a PowerShell script, the extension is .ps1. So it just depends on the language as well as the interpreter that you're using, what the extension of that script would be. So for example, the script that we were addressing inside of our current machine was the flaghunt.sh, and then that's how we know that it was actually a script. So what we're going to do is now we're just going to create a couple of scripts so that you can see what it's like to do so in real time. And I'm going to just use the same name, and I'm just going to keep changing the file, the contents of the file. So the first one is going to be, the first thing that we need to learn actually is how to use a text editor inside of the command line to create a script. And Nano is my favorite one. It is a very basic, very easy to use text editor. And so when you do Nano, you need to give it the name of the file. So I can do Nano flag hunt, and it'll actually open up the flag hunt shell script for editing. Or if I wanted to create a file, I could just give it the name of the file that I want to create. So let's say firstscript.sh. And now it's going to create this file for me, and then it's going to take me into it so that I can start editing it. And as we already established, you need to have a shebang line at the top so that the system knows what syntax and what language it needs to use to start interpreting the rest of your commands. So we have our interpreter, which is the bin bash, and now we can basically start creating some easy commands, okay? So one of the ways that we can do this is to create variables. So one of the common things that you're going to run across is variables and how to create your own variables. There is a way that I can just do name, and I can do name equals John, right? For example, that could be a way that I can create a variable. Another way that I can do it is I can prompt the user to give me a response, and then I can store their response as a variable. So for example, when I echo something onto the screen, I'm basically prompting the person to give me something, or I'm either notifying them or I'm asking them to interact with me. So I can say, hey, what's your name, right? And that would be my prompt. And then they're going to respond with something. And then I'm going to read their response, and I'm going to store it inside of the name variable. I just created a variable called name, and I used their response as the value for this variable, right? So you say read, and then anything you declare after read is going to be the name of the variable. And then I can now refer to that variable, and I can say hello, we'll do this, welcome, and then we'll do welcome name, okay? You can actually reference the variable without using these squigglies, but what I like doing is getting into the habit of using these squigglies, because then you can actually modify the contents of that variable by adding other stuff to it. So for example, I'm kind of just take this a little bit one step further than what's inside of our instructions for this room. So I'm going to say hello, welcome name, and then we're going to say this is, and we'll do this again, right, name, but now I can say apostrophe S, and I can say computer, and now it's going to read this is so-and-so's computer. If I didn't include these squigglies, then the system will actually try to look for something that is called, it's going to try to look for a variable called, you know, name apostrophe S. And we don't have a variable called name apostrophe S, or it's going to give us some kind of a syntax error because you can't typically put an apostrophe inside of a variable. So if I want to modify the actual variable by adding an apostrophe at the end of it, or if I want to add a couple of numbers so that I can make it a unique username for somebody, so on and so forth, when I do that, it's just so much more convenient to put these squigglies so that you can attach anything else that you want to that variable, and then the system will just attach it as if you're attaching any other part of the string. So let's actually run this so you can see what this is like. So we're going to do Control O, and it's going to ask, do you want to save it? So let me show you at the bottom right here. If I do Control O, it says file name to write, which is first script, and Control O is write to the script. So we do yes, write to that. So write out, there you go. Control O is write out. And then so now that I'm done, I can do Control X, and I will exit out of it. And then now we're going to clear the screen again, and it's going to be back at the top right here. And so now we're back at our command. So now we can do an ls, and we can see that we have this new file. But if you notice, the script that we just created is not highlighted green, which means that it's actually not executable yet. So if I do lsla, we can see our two files right here. And then we can also see that, actually, let's kind of make this a little bit easier. So we'll do lsl, and it just shows us the files that we have. This one, you can see at the very end of it, there's an X, meaning that this is actually executable. We can add executable permissions to it. There's X inside of the group as well as the owner. They all have X, meaning that they can execute the file. R would be to read, W would be to write, X would be to execute. This particular script right here doesn't have it. It doesn't have X in any segment here, which means that we need to assign executable permissions to it, because we need to execute it as a script. It needs to run, right? It needs to do something. So the way that we do that is by using the chmod command, which is change mode, and then we want to add. So the way that you add is by doing the plus sign, and then we want to give it executable permissions. So we do X, and then we give it the name of the file. So first script.sh, press enter, and now if I do ls, we can see that it's highlighted green, which means that it is actually executable. It now has all of the executable permissions. Perfect. So this is all good. And now we can actually run our first script.sh file. Boom. It's going to prompt us, hey, what's your name? I'm going to say my name is Hank. It's like, hello, welcome, Hank. This is Hank's computer. So you can see that. Let's actually go look into it again. So we can see that in the first reference, it said, hello, welcome, name. So welcome, Hank. It asked me what my name was. I said what my name was. It read what I gave as a response, and it stored it inside of the name variable. And then the next one is, hey, welcome, Hank. This is Hank's computer. You see how that apostrophe S, how cleanly it was added to that variable? That's how we do it, by using these squigglies, okay? So that is our very first official script. So if you followed along with me and if you actually did this, then you just created your very first script. So very, very cool little instance to do. Now, another way that we can create a script is to loop through something. So we have a for loop or a while loop. And as the name implies, it's just going to keep looping through something until it meets the condition that it's required to meet. So let's go back into our first script shell. And now what we're going to do is we're just going to change this whole thing and create our next script, which is just going to be a basic for loop that kind of moves through something. So we can do this. We can say for I or X or H, whatever. That part doesn't really matter. So for the purpose of this, we're just going to say for I in, and then we need to assign it a range. So it's going to be 1 to 10. And we are saying that for 1 through 10, that's how you talk to the bash or the shell script. Then you want to say do. So for something in something, I want you to do something, right? So for every integer, that's basically why we're using I here. For every integer inside of this range of integers, I want you to do something. And what it's going to do, you have to tab. So that's the other piece of this, excuse me. This is the header of the loop. And then everything under this header needs to be tabbed so that it actually is the body of this specific for loop. So when you press enter, you press tab so that you can actually go into the body, and then you say, I want you to echo, and then all I'm going to do is I'm going to reference my integer variable that I have over here, and I want you to echo the integer. So on the first, and then at the end of this, we're just going to say done, because you have to finish every single loop or iterative statement with its closing command here. So it's going to say for every integer inside of this range, I want you to basically echo it, meaning print it onto the screen for me. So on the first loop, what it's going to do is going to look at the number 1, and it's going to say, okay, 1. And then it's going to loop again, and it's going to go through this condition here, and it's going to say, okay, so I still have some ways to go. So the next one is going to be what? 2. Okay, cool. So I'm going to echo 2. And then the next one, I'm going to echo 3 until it gets to 10. When it gets to 10, it's like, oh, okay, so I'm at the end of my list now. I no longer have to do anything, and it's just going to stop running, okay? So then what we can do, just to kind of make this a little bit fancy, we can say done, boom, just like that, right? So that's it. And that's it. That's very, very simple. It's a very, very simple for loop. And then now it's going to run. And so we're just going to do Control O, press enter, Control X, clear it out or close it out. And now we can do clear to get into the screen. And now we'll do first script, press enter. Look at that. It iterated through the entire range that we had. And then at the end, it said, hey, I'm done, right? Very, very basic, but it's actually powerful. So when you kind of learn that you can combine this with other commands and do a bunch of other things instead of just echoing something onto the screen, then you get where the automation comes in. And that's why the flag hunt, right? So the flag hunt script that we have, you can see that it actually starts with a for loop, and it says for file inside of this directory. So we're going to give it the directory that we wanted to search through. It's going to say for every file that is inside of that directory that has the extension of .log, what it's going to do is it's going to say, if I search through it and I can actually find the flag inside of that file, then I want you to print that I found the flag, right? And so you can imagine that instead of me having to go through every single file inside of that directory to try to find inside of that file this flag statement, it can just do that for me and then come back and say, hey, I found it, here's where it is. And then you're like, yo, what? So that's where it gets, again, just super freaking powerful. So that's why we love scripting. So that was our very, very first script. So let's go and create another one here. So we'll do the first script shell file one more time. And now the next one that we're going to create is a conditional statement. So we already saw that inside of our flag hunt script. So now we're just going to create our own here. So we created a for loop, which is very good. So now what we want to do is we want to create a conditional statement, which is what we call an if statement. So if a condition is met, then I want you to do something. Otherwise, I want you to do something else. That's what an if statement does. The syntax breaks out like this. So First, we're just going to say echo. So we want to get another input from the user. Now, my favorite way to actually do this, instead of doing echo and then read the response, I just like doing this. So this is basically the same way as doing what we did echo earlier and getting the name and then saying this is Hank's computer. This is basically going to do the same exact thing. It's just a little bit cleaner because you can do everything inside of one line. Okay, so we can do read this prompt, which is going to say, please enter your name. Okay, that's fine. And then we'll do first, I guess, please enter your name. I don't need to do all that. Please enter your name. There we go. That's my prompt. So I'm telling it to read the prompt value right here. And then I want you to store it inside of the name variable. And just like that. So that's basically the same as me saying echo, please enter your name. And then on the next line saying read name. This is exactly that, except we just did it cleanly in one line, okay? And you'll hear this a lot from programmers and developers. If you can do something in one line instead of doing it in 2 lines, then that means that you are more advanced as a coder. Simplicity is genius when it comes down to coding. So and then we'll get an example of this in a couple of tasks when we go through the rest of the stuff. Some people like to do something complex just to be like, oh, I can do complex coding. But if I can do the same exact thing that you did in a simple line of code and it took you 12 lines of code, then I'm actually better than you, right? It's kind of a pompous way of thinking, but it's true, right? So if I can actually do something in 1 line of code and it took you 6 lines of code, 10 lines of code, then I essentially have done something better than you, especially if what I did and what you did has the same level of security. Sometimes they'll be like, yeah, okay, it has to be this advanced because it's more secure if we do it this way. And that's their excuse. And I'm like, all right, fine. If it is actually more secure, then fine. But if it's not more secure and all you're doing is just creating extra lines of code for my system to read, and it's going to use up my CPU usage and all the resources of my system just to read your stupid code, then I'd rather you do the short code because it just gets the same job done with 1 freaking line. Anyways, rant over. So, okay, so we just created a variable called name, and the value of that variable is whatever the user is going to input into the system. So the if statement comes in like this. So we say if, and then we have to open it up with a square bracket, and then you have to put a space because it's very important in the syntax of shell scripting that you actually use this specific type of syntax. You actually have to put a space after it. So if we say if the name, okay, equals Stuart, so this is the value that it's like our requirement, right? So if the name equals Stuart, then you do space closing bracket, and then you do your semicolon. Then, so if the condition is met, then do a tab, echo, welcome, Stuart, right? Here is the secret, and then here's the secret, right? THM script. There you go. That's the secret. Else, so basically meaning otherwise. So that's the first condition. If this condition is met, then I want you to do this. If the condition is not met, else, otherwise, I want you to do this. Echo, sorry, you're not authorized to access the secret. Boom. There we go. And then the way that we close an if loop or an if statement is by doing the reverse, which is fee. So basically if backwards is fee. For loops, you do done to close it out. For if statements, you do fee to close it out. And that's basically it. That's our entire script. And now what we're going to do is we're going to save it. So, and then we're going to clear the screen, and then we're going to run it. And then now it's going to say, please enter your name. And I'm going to say, my name is Hank. And it's going to say, whoop, you're not authorized to access. And so what is, it says echo, sorry, da 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 da. Okay, so there's some kind of syntax error. Otherwise, it would just say sorry. So let me go see what my syntax error is for this first script. Oh, you know what? There's no space here. So we can see that there's a space between this one right here. I put the space after the what is that? Quotes. I put the space after the quotes. So there you go. Now that's fine. Now that should be fine, and it's not going to give me that error anymore. So let's write this out, enter, clear. What's going on? Why isn't this working? Save file under different name, cancel, script no, cancel that, enter, we're done, clear that. Okay, perfect, there we go. That was a little bit weird. Okay, cool. So now there's my flag again, or my script, excuse me. I'm gonna do run it, and it's gonna say, what's your name? I'm Hank. Sorry, you're not authorized to access the secret. Oh, okay, fine. Let's run it one more time. What's your name? My name is Stuart. Hey, Stuart, here's the secret, right? So there you go. It worked. Very, very simple script, but powerful. And you can do this with, we're going to do a much more complex version of this in later tasks. But this is one of the simplest ways that you can kind of essentially verify somebody's identity before you give them something. And then you can actually combine it with, it has to match their name, it has to match their PIN number, it has to match their company name, their email address. All these conditions have to be met before the system allows somebody to get in. And we are going to create something like that in just a short while. So that was it for our if statement, and it actually worked extremely well. So one of the other things that I just want to share with you that is inside of our documentation here is going to be the use of comments, right? So comments are more for people who are going to read the actual contents of the script than it is for anything else. So for somebody who is just trying to use it, or for the system isn't going to read these comments and say, oh, I have to process this. The only thing that the system is going to use is actually this piece right here. And it's going to say, okay, that's the interpreter that I have to use. But this part right here where it says defining the interpreter means nothing to the system. It's only for me as the user that's going to open this file and be like, oh, okay, that's what this line is supposed to do. And then in this line, we're asking the user to enter a value. Okay. In this line, we're storing the user's input in a variable. Okay. In this line, we are checking if the name that the user entered is equal to the required name that we have, which is in this case, Stuart. Okay. If it is equal to the required name, the following line is going to be displayed, meaning that, hey, we're going to say, welcome, Stuart, you got in. If it's not, so defining the sentence to be displayed if the condition fails. So this is our condition. So if the name is not Stuart, then it's going to echo, hey, sorry, you're not authorized to access the secret, right? This is the purpose of comments. It's mostly for the person who's reading the contents of the actual script file to know, oh, this is what we're doing. This is what this line is intending to do. And if it breaks for whatever reason, if the script doesn't work, you saw just now where it said on line 8, there was an issue. And then it still kind of gave me the output, but it did say that on line 8, there was a little bit of an issue. You need to go address that. And for me, it was because the fact that I didn't put a space between echo and my opening quotation. So this is one of the main reasons why we actually like comments, because it explains what's going on. And then we kind of know where, along with the system's responses, because the system will also give you a little bit of feedback as well. Using the comments as well as the responses of the system helps you to understand what's going on in each portion of the script. And then if you need to troubleshoot, then you know how to troubleshoot that portion of the script. So comments are for the user who's reading them. It has nothing to do with the system, and really has nothing to do with the end user who's actually going to be using the script. So that's basically what comments are. There are other types of variables, there are other types of loops, there are other types of conditional statements, and we can do a lot of other things, but that is beyond the scope of this particular room. If you're interested in learning that stuff, I do recommend you go check out the other Linux videos that I have. One of them is the most popular video, which is becoming a Linux system administrator, or how to become a kick-ass Linux sysadmin. I think that's the name of the video. That's literally it's the most popular. So if you actually organize the videos on the channel by popularity, that is the #1 video that exists on this channel. And then recently I also launched the Linux Plus playlist. So in that video, there are 3 videos inside of that playlist that actually have command line strategies or command line exercises. And the very last one is all about scripting, and we're just going to create a bunch of different scripts. So We talk about all of these other things inside of that video. So if you're interested in learning more about it, I would recommend you go watch that. So here's our questions. So we have, what is the shebang that is used inside of a bash script? And it would be hashtag exclamation / bin and then / bash. If it was a fish script, it would be / fish. If it was a Python script, it would be / Python. So it's basically the location of the binary that you're going to use to interpret the rest of the script. So in this particular case, we are creating a bash script. So we're going to use bin bash. Which command gives executable permissions to a script? And that is the chmod +x to assign executable permissions. Which scripting functionality helps us configure iterative tasks? So when you want to iterate through something, and that is a loop. So you can have a for loop or a while loop, and both of those are considered to be iterative. So you're iterating through your list of options, for example, 1 through 10, right? And that's basically it. That's all the questions that we got. So let's go on to our little exercise here, which is the locker script. So we're actually going to create a little script, and it's going to be a nice little practical exercise. So let's jump into the locker script. All right, so here's the task at hand. We have the scenario where there's a locker that's inside a bank, and to secure the locker, we have to have a script that verifies the user before they can open it. And they need to verify 3 things. They need to verify their name, their company name, and their PIN number. If they enter all of those things correctly, they get access. If any of these things are incorrect, they are denied access. And here's what it is. The username has to be John, company name has to be TryHackMe, the PIN number has to be 7385. So let's write this script. So this is the example that they give us. I'm going to create another one after I go through this. I'm going to create another one that is much simpler than this, and it's going to exactly accomplish the same functionality. And this is what I mean when I say that, you know, simplicity is genius, because you'll see what I'm talking about as we actually go through this example. So first and foremost, obviously, we want to define the interpreter, which is bin bash. Then we want to define the variables. So in this case, whoever wrote this freaking script, first they create empty variables here, okay? Just keep that in mind. We have empty variables here, and then we have a loop, a for loop that has an if statement in it that is going to fill in these variables, okay? So it goes like this: for I in 1 through 3, basically meaning I want you to iterate through the rest of this 3 times, right? So for I in 1 through 3, I want you to do this. If I equals to 1, meaning on the first time that you loop through this, if the I variable, if the integer is 1, then I want you to ask the user, what's your username? And then they're going to enter their username, and then you're going to read it and store it inside of the username variable. On the second iteration, so when it says elif, meaning otherwise, so if that, then do this. Else if the integer is 2, then I want you to ask, enter the company name. And then else, meaning on the final round, then I want you to ask, enter your PIN. And then, you know, store the company name inside the company name variable, store the PIN inside of the PIN variable. And then fee, which is the end of if right here. And notice how all of this is tabbed. So this is actually all of the body here. And then inside of each one of these, there's another tab which has the body of this if statement. Then there's another tab that has the body of the elif. And then we have another tab which is the body of else. And then fee is aligned with if and elif and else. And then at the very end of this for loop, we have done, which is aligned with for. So this is our full loop that is going to fill in our 3 little variables here. And I mean, if you paid attention to anything that I talked about in this video, you should know how we can do this much simpler than having 15 lines of code that goes through all this stuff just to fill in 3 variables. Now, here's where the actual functionality, here's where the whole script really kicks in. So we have one big condition. So all of this that you see here is one condition. It's just there are 3 requirements in this condition. It says if the username variable equals to John, and so these double ands are required to combine different conditions. You can't do it with a single and. Or ampersand, excuse me. These double ampersands, you can't do it with a single ampersand. So if the username John, or the username equals John, and the company name equals TryHackMe, and the PIN number equals 7385, semicolon, then I want you to echo that authentication was successful. Otherwise, else, I want you to echo that authentication was denied. Meaning what? If the username is incorrect and all of these things are correct, you're going to get denied. If the company name is incorrect, but John is correct and the PIN number is correct, you are going to get denied. If these two are correct, but the PIN number is incorrect, you're going to get denied. So you have to meet all three conditions in order for you to get authentication successful. And that's basically it. That's the entire script, right? So when you execute the script, it's going to say enter the username, John, enter the company name, TryHackMe, enter your PIN, 1349. And then it's going to say authentication denied because the PIN number was incorrect, right? So this is the script that they've given us. What I'm going to do is I'm going to recreate the script for you, and then we're going to test it. And it's going to be exactly the same result that we wanted to give us, except it's just going to be much, much simpler, because instead of using literally, so let's see how many lines. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Literally 15 lines. It's 15 lines of code to get you 3 pieces of information from the user. So instead of doing that, what I'm going to do is I'm going to do it in 3 lines of code. Okay? This is going to be awesome, and you're going to love it, and it's going to be amazing. So let's actually do the damn thing. So we're going to get into our terminal here. Let's make sure we're at the top of the page. Come on, what's going on, buddy? What's happening here? My God. Okay, you know what? I'm going to zoom out a little bit. I'm going to zoom out. I'm going to type this up, and then I'm going to zoom back in so I can explain everything to you. So here we go. And that's it. Look how simple that looks. How beautiful is this script? I mean, honestly, goodness gracious. Okay, so let's see if I can actually do like a command plus here. Or no, that doesn't work. All right, never mind. All right, so here we go. Here we go. Here we go. Those 15 lines of code that got us our values can be accomplished with these 3 simple, beautiful lines. The first prompt is, what is your name? And then we're going to read the value of this prompt and store it inside of the name variable. The second prompt is, what is your company name? We're going to read the value of this prompt and store it inside of the company variable. The third prompt is, what is your PIN number? And we're going to read the value of that prompt and store it inside of our PIN variable. And the rest of the script is exactly the same. So if the username equals to John and the company equals to TryHackMe and the PIN equals to 7385, then echo authentication successful. Otherwise, authentication failed. You are not the authorized user. And that's it. Just like that. We're going to Control O, press Enter, Control X to exit it out, clear the screen, and let's run this thing just so I can show you that it actually does work exactly that the exercise kind of asked us to make this thing work. So here we go. We have the list of scripts here. You can see that it's not an executable yet. So the first thing that we have to do is actually make it an executable. So we're going to do chmod plus X, locker script, boom. And now it is an executable. Beautiful. So now we're going to run the locker script, enter. Hey, what's your name? My name is Hank. What's your company name? It's TryHackMe. What's your PIN number? It's 7385. Authentication failed. You're not the authorized owner. But why? I have the right company. I even have the right PIN number. Yeah, but you don't have the right name. Okay, fine. All right, fine. Let's run this one more time. We're going to run it again. Press enter. What's your name? My name is John. What's your company name? Google. What's your PIN number? 7385. Authentication failed. You're not the authorized user. What do you mean? Why not? Because you didn't have the right company name. you're getting this, you're getting the pattern here, right? So what's your name? John. TryHackMe, right? What's the PIN number? Authentication failed. So all of those three things have to match, otherwise we're going to get a failed authentication. So one last time here, we're going to use locker script. What's your name? It's John. What's your company name? It's TryHackMe. What's the PIN number? It's supposed to be 7385. What? Isn't it 7385? I thought it was, right? TryHackMe, John, 7385. Authentication failed. So what PIN number did I what PIN number did I ask for? Oh my gosh. Let me see. 7385. PIN 7385. Authentication successful. Company TryHackMe. Name John. What did I miss here? Am I missing something? I'm pretty sure I used the right. I'm pretty sure 7385. Yeah. Isn't that what I used? John. TryHackMe. 7385. Authentication failed. You're not authorized. Now I am stumped officially because I thought I was using the right stuff here. So let's see. Maybe I really did mess something up here, because I'm this whole time I'm like, yeah, it's gonna be amazing and da da da. And now it seems like I have messed something up here. So let me see. Oh, see how silly I am. This is the variable name, right? What I'm referring to is username. So that is my bad completely. See, I try to be cocky sometimes and I mess up so bad. So there we go. That should be fine. So press enter, Control O, enter, Control X, exit, out. Watch this work. It's gonna work beautifully. What's your name? John. TryHackMe, and it's 7385, right? Boom. Authentication successful. Yay! We got access to the script. What's going on? Yeah. Sweet. All right, cool. We are officially done with this section. So let's go and answer these questions. So what would be the correct PIN number to authenticate? It would be 7385. I mean, that's a pretty easy question. Hopefully that made sense. So one last thing we have here is our practical exercise that we're going to run with the information that we got at the very top of this exercise. And then we're going to run that one script that we had, that flag hunt script. We're actually going to run it now. So let's do that. And we are going to be done with this room. And I hope you have gotten value so far, and I hope you are enjoying yourself. And I hope you've actually been following along. So that being said, let's do this final exercise and let's be out. The exercise requires that we actually run the script that we had inside of our home user directory, which is the flag hunt script. Now, we need to first switch to a pseudo user, meaning a root user, so that you can actually access the contents of these var logs. So essentially what the script is going to do is it's going to go through all of those log files, and in order to go through the log files you need root privileges. So that's why we need to first switch to the pseudo user, and then we're going to use the username and password that they gave us at the very beginning of this room to be able to do that. Once we are a root user, then we're going to run the script. Now what we need to do is we need to actually fill in those missing variables. So there was a directory variable that we needed to fill in, there's a flag variable that we needed to fill in, and then there's also another section of the script that's inside of our for loop that we need to adjust and fill in var_log over there as well, so that the script can actually function properly. So when we do this, then it's going to hunt through every single log file inside of this directory, and it's going to look for this, and then it's going to say this is located inside of this log, and then when we find it, we're going to get the flag that we need, the final flag that we need, or the final answer that we need. So let's actually go ahead and do that, and we will be officially wrapped with this room. So I hope you are as excited as I am, because this is going to be a fun one. So let's see, where's my username and password here? There it is. So we're going to first switch to sudo. So su, you can also do su sudo, either one works. So su stands for switch user, and sudo is the user that we're trying to switch to. So we'll do that, and it says enter the password for the user, and it is user at, whoops, I already misspelled it, so hopefully I can just backspace, user at TryHackMe. Okay, cool. There you go. That worked. So now I am officially the root user, as you can see over here. Now we need to actually get into our flag hunt shell script, which is right here. And we need to fill in these missing variables here. So the first variable was the directory, which is the var log directory. The next one was the flag. So what was the flag value that we needed to do? That is thm-flag01-script. So that's what we're looking for. And then we're going to fill in this one last missing piece, which is right here. So it says for file in this location, and we need to give it the var log location. And then you can see that the var log location is now going to have the /*log. So basically any file inside of this location that ends with the .log extension, it's going to search through it with grep, and if it finds this flag inside of that file, it's going to tell us where it is. And it's going to be inside of the base name of that file, which basically means it's going to give us the file name. It's going to say it's in this file, right? So that's it. That's the script that we got. So Control O, press enter, Control X, and then now we're out of nano, clear, and we've cleared the screen. Here we go. Flag hunt, enter. Flag searching directory in progress. Flag was found inside of the authentication log. So imagine, okay, let me just do this one more time just so you can get the power of this, because that happens so quickly that we can kind of miss what's going on. So imagine I'm going to list all of the contents of the log directory, and we have all these logs here. So imagine you had to go through this log and go through this log and go through this log and then go through this log and then go through this log. Imagine you had to go through all of them one by one to try to find that one little string, which is the thm-flag01 script. That's insane. It just hurts my head thinking about it. So instead of doing that, then what I'm going to do is I'm just going to create this simple little script, and it's going to search through all of that for me, and it's going to search for that string, which was the flag, thm-flag01, Now it says flag was found inside of the authentication log. Great. So what do I need to do now? And I just need to cat the authentication log. So I'm going to do cat var log /authentication.log. Press enter. The cat is sleeping under the table, and this is what it found. So thm flag script, that's actually what it was looking for. So we know that it's inside of that. And now we're looking for this. This is the answer that we want. So the cat is sleeping under the table. So we get to this screen right here. So which file has the keyword? It's the authentication log. Where's the cat sleeping? Under the table. And boom, baby, we are officially done with this room. So hopefully you found that useful and you actually had some fun as we went through this. And let's wrap up, and I'll give you a couple of final notes and you're free to go. So the conclusion basically tells us that we did a good job, so congratulations for making it this far. If you found this video useful, I do encourage you to like, subscribe, and turn on the notification bell so that you get notified the next time that a video comes out inside of this Cybersecurity 101 pathway that we're going through, because we still have a long way to go, and there's a lot of great stuff for people who are just getting an introduction to cybersecurity. And even if you have been around a while, I think going through these rooms is actually really great because it fills in any missing gaps that you may have kind of skipped over or nobody introduced to you as you were getting introduced to cybersecurity. So I think it's very, very important. I think everybody should kind of go through this and watch this. I even find some things that I'm like, oh, I didn't know about that. And it just makes me more whole. It gives me a holistic, wholesome, not wholesome, holistic, I think, comprehensive. There you go. That's the word I'm looking for. It gives me like a full view of everything, and it fills in all the missing pieces for me. So if you have not done so already, make sure that you like, subscribe, and turn on the notification bell. And now there's this other piece right here, which is all the content that we have on this page, which means, for example, we have all these videos right here. If you have not gone through these videos, or if you have anything that you might even be curious about, chances are there's a video that's available here that will probably answer that question for you. So, we have all of these playlists, and the most recent playlist that I'm really, really happy about is the Linux Plus certification playlist that's over here. And it ended up doing really well. And inside of this certification playlist, we actually have all of these videos. So there is the shell scripting, and I actually need to organize this real quick because this is the first video that we need to organize here. So we have the the shell scripting, we have the command line labs, and we have the lecture pieces right here that are available for you. So these are really, really cool and useful videos, and they've so far been doing very, very well. I've gotten a lot of great feedback from the people who have gone through these tutorials. And so if you're at all interested in anything that has to do with Linux, this would probably be the video tutorial that I would recommend that you go through, and the playlist that I would recommend that you go through. So that's one of the things that's available. And then we have, of course, the cybersecurity 101 that you're currently on right now. There's the SOC level 2, there's SOC level 1, there's PenTester, there's security engineering. There's a lot of stuff that's available on this channel. So if you haven't checked it out already, definitely go and check it out. And of course, like, subscribe, and turn on the notification bell so that you get notified. And then of course, drop a comment as well if you have any questions. I'll respond to your comments. If it's a really, really good question, then I'll go ahead and create a video for you. This entire training series for CySec 101 was inspired by Darnell Knight's comment, and somebody recently in the comment section was like, yeah, we should be thankful to Darnell. And I'm like, yeah, dude, you should be, because that's the guy that inspired the CySec 101 series. So if you have not if you haven't dropped a comment, drop a comment. And if you haven't thanked Darnell, just like do a tag, try to find him. I don't know what his exact username is. I should probably find it and like give him kudos in every single video or something. But yeah, that's basically it. So the whole point is drop a comment and ask any questions that you have, and I will respond to your questions. And if it's a really good one, I'll respond in a video for you. So like, subscribe, turn on the notification bell, drop a comment, and let me know what's up with you, and then we'll handle the rest of it. And if you haven't checked out Hackaholics Anonymous yet, then I do recommend that you check out the Hackaholics Anonymous membership community. It is the membership community that is designed for security analysts and ethical hackers, and you get a bunch of perks. For example, the Python automations, for example, the exclusive content and the exclusive downloads, and the live streams that happen monthly, and the Discord chats, all the Discord servers that are available for all of the members that we have. So you can come in as a cyber supporter, $4.99 per month, and that will get you access to the Discord community. It gets you access to me directly, all of our advanced members, and we'll tag along with you as you go through your cybersecurity journey. Or you can get one of the advanced memberships and get all the extra perks that's attached to it. And of course, if you wanted to, you can do it through the description, the link in the description below, which is the join link. You can also come to the homepage, click on the join button, or you can go to youtube.com/@HankHacksHackers/join, and you will be taken to the join page for Hackaholics Anonymous. If you haven't checked it out already, I highly recommend you check it out. You can watch this little 14-minute video to find out what the perks are, or you can click on this little read more button at the bottom, find out what the perks are. And I hope to see you in the Discord servers. If not, I hope to see you in the comment section. So boy, Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker / protector. Love, peace, and chicken grease. If no one else loves you, Hank loves you. And I will see you in the next video later. Oh, by the way, this is probably going to come out on Christmas Eve. So if you're watching this, then Merry Christmas. If you celebrate Christmas, Happy Kwanzaa, Happy Hanukkah, all that good stuff. Happy holiday season. And, going into 2025. So happy 2025. We're about to come up on our 1-year anniversary of this channel, so I'm super excited that you're here. Thank you so much for tagging along. Thank you so much for being a part of the community, and I just love having you here. So again, love, peace, chicken grease. If no one else loves you, Hank loves you. Later.